Um, yeah, so I wanted to talk about what we've been doing at Walter P. Moore. Um, yeah, I guess taking a look back first, based on some of the other presentations, um, a little bit about me. I think I spoke here 9 years ago from Core Studio, and back then we were looking at how to use AI um, in AEC. And so I think since then I left and I came to Walter P. Moore. But yeah, so I've been trying, I guess, ever since and before to explore AI and AEC. And so yeah, let's get into it. I think the world's always changing. This is at the millions of year pace, but even within our lifetimes, uh, technology has been changing quite a lot. And I think to survive as a business, the notion of creative destruction is really important because it's never going to stay the same. So thinking back on Waltz P. Moore, um, they've been a company for over 90 years, starting in the Great Depression, and originally doing houses. Um, Later doing the Astrodome, but still computations were done by hand. Now, in 1967, with the advent of computers, they were able to do larger structures, but the computers back then took up a whole room. And the computational power on our phones are 500 billion times more than that computer. It's hard looking back to think about 20 years ago that BIM was a thing that was revolutionary at the time. And so thinking about the new wave, uh, the digital practice within Walter P. Moore started around 2010 before I arrived. And we've been thinking about the next steps. Um, so we don't have a core studio, but we do have a lot of people who work with technology, engineers who code, computational designers who code, all working focused on projects. So they spend maybe like 5% of their time, if they're lucky, working on code. This is across a wide range of practice areas. And when I arrived, I was working within the enclosures group, focused on projects. But I develop a lot of my own tools and share those tools. A couple years ago, my role changed, and I've been working across these practice areas, trying to um, extend what they can do. The interesting thing I think about Walter P. Moore and the way that we approach computation on our projects is that it's very integrated. And so all these people are spread across different offices. We've tried to break down the barriers between offices and between the practice areas to focus on integration. So we've been on GitLab for about 8 years, and there's tons of stuff there. But the problem is, and a lot of people contributing, but the problem is that a lot of it ends up in silos. So those innovations tend to work on the individual projects, individual people. They're working on their own tools for themselves. And we're missing a lot of ROI, right? There's tons of people who aren't engaged in that innovative process. So time for creative destruction, right? What do we do? Well, we've thought about how we develop products and how we can engage more of the people. I'm sure a lot of you kind of skew towards the innovation, but for an engineering company, they kind of skew the other way, right? A lot of the work day in day out is like we're in a rush. We need it to be right. It's very hard to try new tools. So we've been thinking about how we can work with prototypes and address, but also maturing products so we can address more people where they are and at their comfort level. And so picking on agile development, we've basically categorized and created a language around these different evolutions of the product. And we've formalized this into a fairly common idea of an innovation funnel. So we have several products. They're spread through ranges of development. And we've made a web app to make these more accessible to people. So within the innovation funnel, people can come and they can see how mature or how stable a product is, and then they can interact at their comfort level. One of the things that we've been doing is taking this concept that we explored back at Core Studio about supervised learning and how calculations can become emulated, right? And in an ideal world, you can toggle between based on your comfort, because calculations, they could be slow, but you have a lot of trust in them. Whereas an emulator can be super fast, but maybe it introduces risk. So we created a system where people could contribute their calculations. It's available on the web. Anyone in the company could contribute. It's mobile friendly, it's chat friendly. And so we basically built the environment, not necessarily knowing who would contribute. And we actually had a bit of a struggle. I mean, I'm sure that you can imagine engineers being hesitant about risk, not wanting to try something new. But we decided to have a collaboration and work with some of the engineers to test it out. So we had engineers that they don't code, they mainly work in Excel, and they wanted to see if their retaining wall calculation, I know it's not a very sexy thing for this crowd, but they wanted to see if this would work and if it would outperform their current usage. So we set up a little challenge. We made a game, and this is the design space. So we gave a couple engineers the task of trying to find the optimal configuration of the geometry, and a couple engineers, they both took different routes through the design space, but they both were around 20 minutes. So that's for one. And looking at some other projects where you can have a variety of situations, and you want to explore like different conditions, that this can easily explode to being like 30 or 40 different scenarios, and each of them would take 20 minutes, right? So using our system, we basically get instantaneous results. And we've also done it in such a way that we can guarantee that it's right, which for an engineer is super important. It's all accessible through an API, so they can use it in Grasshopper, they could use it on our web app, on their phone, or within products that we develop downstream. So now we can automate basically everything from this scenario in real time and correct. So now you can imagine that we have a case for spreading to our engineers, and that they can contribute to this platform. And the idea is essentially to encapsulate these functions almost as if it was knowledge. And then we serve as this power distribution network, so that these engineers who don't know how to code, they can work on their individual tools with their domain expertise. And then through our system and through the apps that we develop, we can just distribute that knowledge to the end users. So one of these applications I want to show is Project Lightning. The idea was to basically accelerate early design. I'm sure this looks familiar. but it's engineers that are working on this. So there's various different entry points, whether it's a sketch or a chat or whatever, and the engineers can do various studies. They feel comfortable doing this. They're excited about doing this, and it's built on a common data layer. So all of the we can basically plug into other apps downstream of this, whether that's embodied carbon tracking or Revit for documentation or analysis. And so thinking about data and how important it is, I'm sure we all know. By doing this, it gives us opportunities, right? So it's I think a lot of people within our company have known that this is valuable, but it takes a lot of effort to implement. So I want to show you an example of what data can give you. This is completely generated. So taking a floor plan as a prompt, you can see our engineering layout. And to me, this looks believable. We haven't tested it, so I don't know, but it looks believable. And it's not just one design, it's many designs. And it's not just one floor plan, it's any floor plan. So a lot of these look like scribbles. They're not necessarily perfect, but I think that there is, this makes me excited. We showed this to the engineers and they said, I'm not using that. So again, creative destruction, this time for ourselves, and that we needed to take a new approach. But we knew that there was something here, so we had continued the dialogue with them. So the question is not really, do we use human intelligence or do we use artificial intelligence? It's how do we get better design intelligence? And through that conversation, two different things came out. So I'll show them one at a time. First is an app that we call Trace. So, and these are both focused on shear walls, basically. So there used to be a practice where you would take a set of drawings and you'd put a trace paper over top and you'd sketch out. And you can try more than one option. And if you did a hand calc, you could calculate how well it did. So they like this. They like the idea of like a real-time feedback, but the creative control. And so we'll do a bunch of calculations and give them information, and they have the control of what they do, and they can look at one design or other designs, compare them. The other thing was that showing them that we could access data, that we could see their plans, and that we could look at similar plans, that we gave them an app where they could upload a drawing, and then they can get what are the other similar drawings that we did at Walter P. Moore, and what did they do on that project. And so even more than just the drawing comparison, we have you can look by system, you can ask questions, and really peek into the data and ask questions and find out what you want to know. So it's maybe not so much about AI, so much as it is about a culture of innovation and trying to reach our teams where they are. They're focused on their projects. They want to participate in technology, but they want to solve the problems that they have and free their creativity. So if a tech doesn't exist, we'll make it. And we're not just trying to make one thing, but we're trying to work for this sort of sustainable future where we create technology, that technology helps us, that technology helps us to continue to get better and better and better. So we're not making one product, but we're creating a system where we can continuously improve. Thank you.